A DNS resource record is information that is related to a DNS domain. For example, the host record defining a host IP address. Resource records are represented in a binary form in packets when queries and responses are made using the DNS. In DNS zones files, however, resource records are represented as text entries. In Windows Server 2008, resource records can be created using the DNS console or the DNS CMD command line utility. Most resources records are represented as a single line text entries. If an entry is going to span more than one line, you can use the parentheses to encapsulate the information. To make it easy to read, blank lines and comment after are inserted in the zone files and are ignored by the DNS server. Comment always start with a semicolon and end with a carriage return. The DNS database consists of resource records that relay different information about the names in the database. A resource record for the DNS name can identify a single resource within the network, such as a network host that uses that name, or that there is a service running on that network host, such as an electronic mail. Different types of records provide DNS data about computers on TCP/IP networks. The most common resources are the start of authority, the host record for IPv6, the name server, mail exchanger record, the CNAME record, and the service locator record. Let's talk first about the start of authority resource record. Every zone contains an SOA record at the top of the zone file. And SOA record indicates that the starting point or original point of an authority for information stored in a zone. It contains all of the zone-specific information for the DNS server to use when maintaining the zone. The ZOA resource record is the first resource record that is created when creating a new zone. Then we have the name server resource record, or NS record. The NS record identifies a DNS server that is authoritative for a zone, that is, a DNS server that hosts a primary or secondary copy of the DNS zone in question. The name of the DNS server that is authoritative for a zone is stored in the R-data field. The NS records are used to indicate both primary and secondary DNS servers for the zone specified in the ZOA resource record and to indicate the DNS server for any delegated zone. If a zone has multiple authoritative servers, you need to have an NS record for each server. The Windows Server 2008 DNS Server service automatically creates the first NS record for a zone when the zone is created. You can add additional NS records by using the DNS or the DNS CMD command line tool. Then in our list we have the host records. For IPv4 is A, and for IPv6 is A, 4 A's. The A record resource maps a fully qualified domain name to an IPv4 address. The 4A record performs the same functions except that it maps a fully qualified domain name to an IPv6 address. The PTR record performs the refer function of the A record by mapping an IP address to a fully qualified domain name. The mail exchanger resource records specifies a server that is configured to act as a mail server for a DNS name. The mail server identified by an MX record is a host that either processes or forwards mail for a DNS domain name. Processing the mail means either delivering it to an address or passing it to a different type of mail transport. Forwarding the mail means sending it to its final destination server, sending it by using the simple mail transfer protocol to another mail exchange server that is closer to the final destination. To improve the reliability of the mail service for a domain, you can designate secondary mail servers that they can store mail for a domain. If the primary mail server stops responding, the secondary server can hold the mail and then forward that mail when the mail server comes back into service. A single mail transfer protocol, Smart Host, uses multiple mail servers provided you with the configuration of multiple MX resource records. The alias record or the CNAME resource record create an alias for an unspecified fully qualified domain name. You can use CNAME records to hide the implementation details of your network from the clients that connect to it. CNAMEs also allows you to make background names changes without affecting the fully qualified names the user and applications are using. This might be a good option if your network might be experiencing growth or major upgrades in the near future. And finally, we have our service locator resource record, which enables you to specify the location of servers that provide a specific network service over a specific protocol and in a specific domain. SRV records allows you to have several servers offering a network service and to move services between servers without changing the client configuration. For example, if you have two application servers in your domain, you can create SRV resource records in DNS that specify which host serve an application server. Clients applications that support SRV records will use DNS to retrieve the SRV resource record for the application server. And finally, for our lesson, we are going to talk about zones transfers. Replicating record changes is necessary so that the secondary servers are updated with the most current DNS information to provide to its clients. Standard DNS zones perform zones transfer that we have been talking about it before. These are used to replicate these changes. DNS servers can host one of the following two roles in the replication process. Master server, which provides an update DNS record information to secondary server, and slave servers that gets its update from the master zone transfer specified on the zone transfer tab in the DNS. A standard DNS server uses the SOA record for a zone to determine when updates are needed. Contained in the SOA record is a serial number that increments each time a DNS zone is changed. Secondary partners use this serial number in determining whether a master has any change for it. The process of updating zones files is always initiated by the secondary server through the following process. First, the secondary server requests a copy of the current SOA record for the master primary server. The SOA includes a serial number that increments for each change written to the zone file. Second, when the secondary server receives the SOA record, it compares against its current record. If the serial numbers are different, the secondary server requests a zone transfer. And third and finally, upon receiving the request from the secondary server, the master initiates the zone transfer to the secondary. The zone transfer for the master to the secondary server come in two varieties: the incremental zone transfer and the full zone transfer. I'm not really going to talk about it because we already explained it earlier this lesson. But just for a reminder, the incremental zone transfer send updates of the DNS zone only to the secondary server, and the full zone transfer send entire zone's data files to the secondary server. Well, students, I hope this lesson was as much as useful as I think it was. If you have any questions, please feel free to post it on the discussion board of the week.